All right. Hi to all the .NET ninjas, and I hope you're all doing well. Today, as you can see, we're going to talk about the console. There's not much to say about the console. We've seen it, and many of the things that you're going to see today, we've already seen in other demonstrations in the previous lessons. But nevertheless, I think there are a few quite cool examples that we're going to run into today, and I recommend you to download the demos of this lesson and review them. At least one of them is super cool, and and I'm going to produce another. I'm going to show you another demo besides that. Which I'm going to try to share somehow, maybe on the Academy Facebook, or on the forum, or on the news group, or maybe through my blog. So we're going to see. So most applications that you're going to build for Windows and web do not involve the console. Usually the interaction with the user is through what you know in other applications, through text boxes and buttons and checkboxes and radio buttons, and you're going to have the chance, hopefully, to play a lot with those. But for the sake of the simplicity of learning the syntax and the language, we're playing a lot with the console now. And there's not much to do with it. Actually, it's just a black window, and it's using for reading and writing text, as you already know, and we're going to see a few enhanced examples of what you can do with the console. Besides, since you're all geeks and you're quite powerful geeks, playing with the console is a good practice for you to prove that you are geeks, because most users just want to click something and that's it. So console is a good geeky place to be. Everybody playing with the command line is very neat if you want to show off. So, as you already know, the console is used for displaying text. It can also read text from the user. Some of you have already implemented some text readings in your homeworks, as much as I could see in the exercise sessions. So that's about it. We're going to see some samples of how text can be formatted, with or without different colors. We can position text on screen. We can play with it in all kinds of ways. So the base class that we're using, not really the base class, but the class that we're going to be using all the time is the system.console that you're all using. If you are including the system namespace in your project, that means you have using system at the top of your file. That means you can just write console. And for the sake of being accurate, most of the methods that we're going to be using on the console are static methods or static properties. So you can just write the name of the class console.something, for example, write line or read line, and then this will get you to the function that you need. But this you already know. So these are the basic methods that some of them we've seen. We have three methods which are used to read input from the user. We have the read line, which reads a whole line. That means that it waits for the user to press enter and then reads the whole line. There's the read key, which reads one key which the user presses, and there's the read, which reads a single character, which of the two, if I'm not mistaken, the read requires an enter at the end, but it will read only one key. Same for write. We have the option to write line, which many of you have been using, and we've seen it in all the demos so far. And there is also write, which just writes at the current point of the cursor. It doesn't break lines, so you can do a lot of things if you know how to place them, or you can, instead of writing separate strings and merging them together, you can do many write statements, and they will write just one after another. And you can control when you're going to break the line. Well, these examples should be quite trivial. We've seen a lot of them. The top one, we can see an integer, and just if we do console.writeLine, we put our variable, and it will print out as text. Same goes for floating point numbers. I'm going to show you a few more examples of how floating point numbers can be better formatted for the console. But this thing we've also run into already. We have those string formatting, which have those replacement variables in them. So we just place a string inside the method. In this case, console write. That means it will not break lines. And the first variable, which is marked with curly braces and 0, will be replaced by a. And then the second one, which is counted as number 1, because we're counting from 0, will be b. And then as number 2, we're going to place the expression, which is written here, a plus b. And the result will be production of this line. It's pretty clear, right? Same with strings. We've seen it a lot. We have here a string variable which contains this string. Writing it down will just produce it. And the same, we can use the replacement arguments inside our string for both strings or numbers. So as I explained, such a formatting of string is quite useful, not just for the console. Many times when you have a string which is, we have the structure, but we don't know what's going to come into it, and we can easily replace things inside the string. That's useful when you have multilingual applications, and you can have a set of strings which represent all the texts that appear in a single language, and then you can have all the texts in a different language, and the order of things can change. The text could be ordered from right to left or from left to right, or that maybe in other languages the position of the variables is different inside the string. So in that case, you can just place your placeholders as you want, and whatever you do, you just place your variables in the right way, and they'll be replaced in the right order. So that's pretty useful, not just for console. Here's an example. I don't think there's use in going here line for line, but I think it's pretty self-explanatory now, right? If anybody has any questions about it. And another one, again with the numbers, again with string formatting. One thing that we see here, which is a bit different, we see that we have a floating point number of pi, and we see that we can format our floating point number. That means that we can cut as many digits as we want after the dot. This writing with a column inside the replacement variable is quite useful, and it can help you format strings. I'll show you more of that in demos. Okay, again, all kinds of string manipulation examples. We have all kinds of numbers and strings, and once we have the variables set, this can be taken from a database, this can be taken from user input, this can be taken from another application. Once we have the variables, we can construct our output nicely, place everything in the right place, and we'll get a nice printout, hopefully. Okay, let's see some demos. Is this the one? No, that's not the one. One little comment. I'm using an extension of Visual Studio, which is called Power Tools, which has a few nice features. One of them is replacing the Solution Explorer that is usually used, this one, with Solution Navigator. And the best feature of the Solution Navigator is that it has a collapse all feature. So if you have a big project like this, or if you take a look at really big projects like Sitefinity project, which we have here, this could be very useful. So this gives a better view.
Other options we get with Solution Navigator. What other options we get with Solution Navigator?
With Solution Navigator, if you have classes, they could be expanded right from here. You can see the members of each class, for example, which is quite neat. You can just.
I want to get this button for a new project.
Is that? No, that's a new window. They don't have a new project.
Because clicking right, then go to the main menu or to the new project.
Yeah, but this button is actually quite neat, because if I have this project here, and I have many projects and it's a big thing, I can click this, and I get another window of the Solution Explorer, which isolates only the route that I chose. So it could be quite nice. It has many other options. This Power Tools is a good extension, and it's quite neat. So let's see what's going on here. Maybe get it visible like this. Okay, so strings and numbers and formatting them. Now this is a console write. That means that we're not breaking the line. So we are printing one formatted string here with the strings with our variables inserted. And now we're writing again with console write, and we're just adding to the end of the previous string. We're not breaking lines like in the previous examples. Now we have a console write line. So it will write and break to the next line, so that the next write or write line statement will be already on a broken line. So this is the next one. If we put console write line with nothing, what will happen? We're just breaking without any text. So we have now a line separator, so that the next write or write line statement will be one line below. Okay, this example that we've seen with two variables and an expression, and you could see it's also done with two different write arguments. That's another example, again an expression, but this is on a different line. Formatting floating point numbers. You could see that this is limiting the float to 2 places after the digit, so our big floating number here is reduced to only 2 digits, decimal digits.
It can be commas with after the 2 points, 0.9.
Yes, we'll see that. That's what I wanted to show as well. So in this last sample, we have all kinds of variables, and we're printing 1, 2, 3, 4, 5 lines. Pretty clear, right? I don't think there's any more to explain here. All right, let's go on. Reading from the console. Notice that we have here, and we'll see how we can read other types which are not string, But actually, all the data from the console comes as strings, and it has to be converted. So if you're reading something which is numerical, you have to convert it into your number variables. And we'll see how this is done. Some of this we've already seen. I've mentioned conversion methods, and there are other ways to convert. So we're going to see these two methods first, the read and read line. So the read function. Read would get a single character, and it would wait for enter to be pressed. So what we can see here in the sample is that when we call read, it returns the code of the character which is being read. So we could reconvert that into a character by casting it into a char. And this would print out the character itself as it is converted back into a character, and I, which is an integer, which is the value, the code of this character. All right? Let's see it live. So, after this line is executed, the console now waits. The application is still running, but it will not continue until there is data in the console. So if I type a character, I'll have to press enter because read expects an enter key. And now we are continuing to the next line. And the data is read into our variable. We can see the value of what I read is 100. That's the code of the character. If we cast it into a character, we'll see that it returns back the character that I pressed. And here the printout would take the character itself in the first place and the value of it, the code, in the second place. And that's what it looks like. Read key, on the other hand, doesn't wait for enter to be pressed. So if you are using read key, you can just let the user click any key, and there are two things which are returned here. We can see the key has a character code, which is just like when we're reading a character, and it has modifiers for any special keys that were pressed down while the user was pressing the key. So for example, Shift, Alt, Control, all these special keys will be represented by modifiers. Let's see it. Okay, again, the console now waits for my input, but whatever I press, for example, have to be, is it now? Oh, you have to execute the first line for it to wait. Let me restart that. One thing that we saw here in this bad example that I gave is that the console actually waits. It's actually referred to as a stream of input. So this is not a blank document that waits for you to fill it. Once there is a pressed key which is awaiting, it will be read in. If I'm pressing a key, it will be, and I'll continue to the next line, it's no longer waiting for a key, it's already read into the stream, into the input stream. That could be useful. I'll try to give another example of that in a minute. But let's get another reading here. I'll just return the cursor of the debugger to the previous line. and I'll press a key with some modifiers. We'll run the first line again. So now the console is waiting for my key press, and I'll press some key with modifiers. Now we're back in the debugger. We've already read the information. We could see that the key that is returned here is a complex type. We can see what it contains if we expand the debugging window like this. We can see the key that I've pressed. We can see the character code. We can see that it has a modifier because I was pressing Control R. So I can actually analyze exactly what the user was doing at that time. So next we're just putting an empty line, and we're printing out the character which was read and the modifiers that were held down.
We are using read key here. If we use read one, is it going to read before we
No.
It's just for the read.
Read and read line, read until the user presses enter. If you want to interact with the user in a way that you're waiting for a key press, then you have to use read key. Let's try to make something slightly different. There's another property here which is called key available, which tells you whether there is a key which is already pressed, or if the console has a stream of keys which are pressed already. Each one will be read to the next, and on each one we'll have this key available set. It's a Boolean which is set to true or false. One thing we could do with that, for example, is get some kind of a loop. Let's get an infinite loop for now. And let's read a key. We'll see it running in a moment. Hopefully it will run. Okay, let's see what happens now if it runs. So here we have an application that runs an infinite loop. We'll cover loops in further lessons, but you could see that while loop is running within this block from between the curly braces, and it has a condition, and during the time that this condition is set to true, it will keep running the loop. And since I gave here a hard-coded true value which never changes, that means this loop will keep running forever. And what it does, every time the loop runs, the application sleeps 300 milliseconds, and after it sleeps, it's checking whether the user has pressed anything. If the user has pressed anything, this data is being read after the user is pressed into the key variable with console.readKey, and being printed out what the user is pressed. So this application just runs and sleeps, and Right now, it keeps sleeping and checking, sleeping and checking, and whatever I print, we can see that it reacts. So if you have some application that you want the user to press something or do something, and you want your application to wait and then react immediately, or things like that, we'll see a much cooler example than this, but this is quite nice to know.
Why are you using this list? Because you don't want to break the excessive time?
Yeah, if I don't, it should work if I don't use the sleep, but let's try to see what happens to the processor at the time. No, it's still responsive. It's not crashing the processor, and it's not making it go 100% CPU usage, but in such cases it's usually better to let the process sleep a few milliseconds before, and not getting it racing too much on an endless loop that does nothing most of the time. So fortunately it doesn't break it, but it's not the best.
If you are not waiting for a key, it will break.
Yeah, there's a chance that if we don't do anything at all, like this, well, still no. Still.
It's a bit hard, the CPU utilization.
Mm-hmm. Well, it could be worse than this. Yeah.
One CPU machine.
Oh, my laptop is a monster. Okay. So far, so good. So read line is the simplest of them. Just reads a line of text and waits for the user to press enter and reads the whole line. So here we have an example of a console application which is interactive, asking the user for first name, and then reads the line when the user presses enter, last name, reads the line, and then prints both variables in one line. So let's see. Actually, let's just run it. Notice that the first statement is console write and not write line, so my cursor is right here, right after the statement is written on screen. It's not in a new line. Let's break just before the writing. We can see the variables are set and printed out as we could expect. Let's put a zooming tool. Questions about this? All right. So we've seen that actually most of what we're reading is strings, and what the console returns when the user input is strings. If we're expecting a number, we'll have to explicitly convert this number to be a number if we want to check its value, to do some mathematical operations on it. And there are a few ways to do that. The easy way is to use the number class. All the numbers classes, if it's an integer or a float, have the parse method that tries to parse, that means it tries to identify the number inside the string and then puts the number inside a number variable. If we put an invalid input, that means that the string is not a number or it's a mix, then we will get an exception here, which is nasty, but unfortunately you'll be seeing a lot of exceptions in your life, as many of them as you want. So that's something to take into account. There are many ways to go around exceptions, and we'll see one of them to avoid in parsing numbers. Yeah.
Is there a difference between using just int.parse and int32 or int64 with capital I?
No, I think that it's only as the variable that it produces. It would return you the variable of the type that you are using. So if you're using int, it will return the regular int or int32. If you're using int64, it will be int64. If you're using float, it will return float, and so on. So, an example, and we'll see it, I guess, live. We have a complex line here that reads from the console, takes the result, and throws it into an int parse function call, takes the result and throws it into an integer variable. Same for the second one. Once we have numbers, we can play with them. For example, there is an addition, a sum expression here that takes both variables, prints them out into a formula, and then prints out the sum. Or multiplication or division. In this case, there's a third number read here, which is a float. Again, reading the console, parsing it, and throwing it into a variable. Another way to convert that I've already mentioned in the previous lesson is to use the system convert class, which has many functions that convert to many data types, and they can also accept many data types in their input arguments. So instead of using int.parse, you can also use convert to int32, and you can give it a string, and it will try to parse it and put it into a string, into an integer, into a float, long, string, whatever you choose to. Again, if you try to feed it with the wrong format, it will crash. So let's see it crash. Okay, let's see it not crash first. So like this. Is this clear, the console window, or should I zoom into it? Is it clear for the people who are in the back?
Can you zoom a little bit?
Is this better? Okay. I hope you don't get dizzy from this, but we'll have to go back and forth a little bit. Let me try to. Okay, maybe this is better. But almost. Okay, something like this. So we've printed the A equals. The next line is running now, so the console is waiting for my read line. That means I have to type and press enter. Then we continue to the next line. Now the int.parse method is called, so that means that the value here, which is a string containing 60, we'll try to parse it into a variable. And it worked. Now A contains the number. Now B is printed out. Again, reading. Enter. Parsing. Now we have a write line statement. So we're going to print, first of all, the first argument is the variable A, the second argument is the variable B, and A plus B is here. So this is the output. If we hadn't converted those into numbers, what would happen to the output here? Yeah, it would take it as a string, and it would concatenate the two strings into one, and we would get 6085 as a string. So here's a multiplication. Hopefully that's correct. Now we're reading the float number. Okay. Here is our line, and here is our parsed float. And now we have multiplication and division. So this is what you get. Nothing more about this, I guess.
If we use comma, then it will crash.
No, this once the oh, you mean, I think it will crash. We can try. You mean because in different different cultures and different languages, I mean, I think you're using commas for numbers, or
Yes, and Telerik it's for numbers. Well, for floating point numbers
it's the comma.
yeah.
Yeah. Okay. These things are determined by the culture that the application runs in, and I think we're going to see an example of that too. But let's rerun. Actually, instead of rerunning, I'll just take the running cursor and I'll drag it back up. So we're starting from the first line again. Actually, let's not start the whole process. Let's go back to the float. So I'll drag it down here. So you would write something like this.
Yes.
I think this will crash. Didn't crash. But it read it wrong. So it took it as 1,000 separator in my sample, because in the culture, in the current locale of my system, point is used for floating point, and comma is used for 1,000 separator. So it thought that I'm using 1,000 separator, and it turned it into probably because there are not enough digits. Let's try again. Let's read it again. Yeah, Actually, it ignores it. Yeah.
And what if you try to parse to int a string that has a floating point?
What do you think will happen? Let's try and see. Okay, let's read an integer with a floating point. It hasn't parsed yet. Now it has. Yeah. However,
The cable connector.
Oh, really? Oh, we're back. However, let me open the watch window for 1 second. No, still crash. Yeah. Sorry? Yeah, we try parse, it won't crash. But we'll see try parse, I think it's our next thing. Any more experiments?
What about the special symbols? Reading them with shift, with control?
Those are read when you are pressing usually a key. They'll be read as key modifiers. Otherwise, it's the console reads a line of text, or it reads a single character with the character's code, and that's it.
So it's a character codes, not
It would read the code of the character in combination with the keys. So, yeah, our next thing is to try parse. That means not to force it. There is also a method called try parse, which is just like parse, but it's more forgiving. And instead of crashing, it will return Boolean indicating. Oh, again. It will return a Boolean indicating the success of the parsing. So if the parse failed, our application will not crash, and we'll just get a notification that the parsing was not successful. If the parsing is successful, our variable will be assigned with the value. As it says here, there's another option with the try catch, but since we haven't covered exceptions, I can show you how to try and catch an exception. Okay. So we have here the function to read line. So now it's waiting for my input. This is our string. We have a number variable which is not initialized, so it has a default value of 0, and we're calling try parse. What try parse will return will determine how the next statement will be executed. This if says if the value returned is true. So since the value returned is false, our number is not changed, but this whole expression here is equal to false. So the parse for an int didn't work, and we can handle it in any way that we want, like print a text. Yeah.
Does out the before a number?
Mm-hmm.
Yeah. Yes.
Oh, good question. Try parse is a function, and it receives, in this case, two arguments. Okay, one of them is the string, the second is the number. But out indicates that it is returned out of the function. That means that it's supposed to be assigned or changed by the function. Usually functions have a single return point. This function returns Boolean value. But in this case, it has to also return the value and set the value to our variable. So in this case, you can indicate the variable, the argument with out. That means it's not just returning a value, it's also changing the value of your argument. So it's not extremely common, because most functions written have just a return point, a return value, and that's it. But in some cases like this, we have to also...
Is this something like passing a parameter by reference?
Yes.
Uh-huh.
In fact, I think we mentioned it maybe when we were talking about data types and variables, that in C# and the .NET world, variables are split into two types, basically. There are the reference variables and there are the value types and reference types. Value types, like numbers, are stored on the stack, and once you pass them to a method, they will be passed by value. Reference types are stored on the heap, and they are all, in most cases, transferred by reference. So it's not needed to be explicitly said that this variable is going to be changed by out, but I mean in this case it is necessary because this is a value type variable, and it's also good practice that if you're changing something, it will be specified.
I have seen instead of outs ref.
Yes, there are.
In this case, will be the same result?
You won't be able to call it, I think, because this is by the definition of the method. It will not compile.
Uh-huh.
It has to be, it's defined as an out variable. That means that it has to be sent as an out variable. It's the signature of the method. But let's not get ahead of ourselves, because I suspect some people are not aware of all this. Okay, let's get a number which is valid. And now try parse. This whole expression will return hopefully true. So we fall into the first option of the if statement, and our out variable, our number, is assigned with the right thing, and we haven't crashed.
So we can use it in a while cycle.
Yeah, if you want to repeat this action, you can use it in a while cycle. Yes.
So we enter the value.
Yes. If you expect the user to input a number, and the user is inputting a wrong number or a bad string, you can use this if statement like this to check, and then say you haven't, and read again, and if he doesn't, you read again until the user puts the right.
But we need to initialize some Boolean Boolean.
Yeah, that would be a good practice.
Because
Yeah.
we want to ask for something after the while.
Yeah. So you'll have to keep track until you know that that would be probably the condition of your loop repeating itself.
Yes. And we have to set this Boolean type before the while operator, because if we rerun the program, it will give us the last the last condition.
Mm,
True or false.
yeah.
And we are setting just the Boolean variable to true. After that we are cycling it. If it's true, then we go again and again.
You are the developer. I mean, in such cases where we have to read input from the user and we want to validate this input, in many cases we don't want to continue execution until the user enters a valid input. So if in this case we want the user to enter their age, we can check all kinds of things, not just that it's a number. It could be a number in a specific range of numbers, for example. So we can set a variable, Boolean one, that will check whether the data is valid. And as long as it's not valid, it will be valid only when we get what we want. And until it's valid, we are repeating and repeating.
Yes, and we can insert in this Boolean type a lot of options. Of course, we can set if he wants to cancel the program, we can write another if.
Yep, definitely. Definitely. Okay, any more about this? One thing that was mentioned in the slide is another option to handle errors. I'll just show a small sample of this. So here's pretty much the previous example of using parse. We're reading, it's a number, we're parsing it into an integer, and we're printing a message. But let's run it again. If we try to parse and crash, we get an exception. That means our code crashed into an unknown execution. What we could do, if we still want to use parse and not try parse, we could use try to wrap our code. You'll see a lot of that when you handle code exceptions and error resolution. But those blocks are usually referred to as try-catch. Once you have an error, you can catch the code That's what it looks like.
Or then you write it numbers.
So I'm reading a number string from the console, and instead of using try parse, I'm just trying to use parse. If I crash within the boundaries of my try block, I will fall into the catch block. So here I can handle the user errors just like the try parse did. No. This is usually a safe, when you are writing code which you know that has some chances of crashing in any way, it would be safe to wrap it like this with try and catch. Otherwise, your application just crashes, and that's quite nasty for the user. If you know that there is a chance, or if you find out that there is a chance, or in any case you want to play it safe, you can catch the exception and you can handle it nicely inside your code.
It's catching all type of exceptions.
This type of catch will catch any type of exceptions, but since there are all kinds of crashes, all kinds of exceptions, you can also specify, for example, divide by zero exception. If I know that inside this block there is a division by zero possible, if I want the user to input some numbers and then I want to divide them and I want to make sure what happens when we end up with a zero division, what end up with other kinds of exceptions. I can also specify the most basic exception, which is the class exception, and let's call it EX, for example, and we can handle it. For example, I can write down details of my error into the console. So now, if I enter a first read, then the console. Now, when we're trying to parse, we're going to crash. But we crash into the exception block. Our program didn't really crash, it crashed internally. We can see here, once we progress to the next line, that we can get information about the string, about the exception, about the crash. And now we can continue execution. We can tell the user there's an invalid input, and we can also print out the details of the exception, which is quite neat. Cool? All right, more examples. Okay, multilingual support. One of the tasks, also I mentioned it I think in the previous lesson, one of the tasks from the previous lessons was to print out the copyright symbol, right? I don't think that was the actual problem there, because it was to make a triangle on the screen, which was the bigger deal. But I guess some of you have run into some problems displaying the copyright symbol, and I think we have also, I demonstrated something related to that in the previous session. And this line here is the one that sets the encoding of the console itself. That means that once you specify the output to be encoded as UTF-8, also known as Unicode format, that means that your console should support Unicode characters. That means international characters. So there is some Bulgarian text here. There is some Arabic text, which I checked with Google Translate, and it says hello. Doesn't say die infidels. This I wrote, it's hello in Hebrew. We have here, like mentioned, a floating point number that could be printed as a point or as a comma, depending on your system culture. Here we are setting the culture of the current application thread. If you're writing multilingual applications for Windows, it is important to get them to display the right text with the right encoding, so you can set all kinds of culture. Cultures in .NET framework are combinations of languages and locations. For example, if we have an English application, it could be American English, it could be British English, and those would behave probably differently in different formatting, for example, of dates or times or strings or floating point numbers. It's not just the language itself. So culture covers this whole field of displaying texts and formatting strings, and your default culture, which is running, is usually referred to as the invariant culture. That means the neutral one. But we could set here any other culture. I think we have to create it. So for example, this would be the British English culture, or this would be the Bulgarian culture, or the American English culture. And in this case, the default neutral culture. So let's run this and see what's going on. No, run. Run. No. So we can see that we're setting the Unicode encoding to the output, and then we're printing a few lines. But we can see that it's not quite what we expected. The reason for this is that the default font of the console doesn't support multilingual Unicode characters. So one option is to set an international font to your console. For example, this font, Lucida Console, supports better. And if we run the application again, where is the console? Here it is. So we can see the Bulgarian text is displayed correctly, but the other texts are still not. Now this is also a limitation of the font, because what I can show you is that if I mark this text and copy it, and go, for example, to Notepad, not like this. Sorry if anybody is dizzy. And I'll paste my text. You'll see that the copied text actually is international text. So this is just a display limitation of the console here. But you can see that the text is really now encoded correctly in international Unicode support.
Is there a way to change the font automatically with C#?
I think it's quite tricky. I'm not sure you would be able to do it. I think you have to dig a little deeper than just what the wrapping layer of C# allows you to do with the console. Basically, it's possible. You can do whatever you want in Windows, and there's another layer called WPF which allows you to control any aspect of the display pretty much, because it uses the same architecture which is used in gamings. But just to do it simply like from here, that will be, I don't know if it's possible, and I think it will be a lot of work, and probably will have some interoperability with this lower levels of.
132.
Don't know if you have to dig that deep, but you'll have to dig deep for that. So as close as we could get here is to see that the actual text printed is correct, and as much as my installed fonts and current operating system culture allows, that's what we can see. But we got the copyright sign, yay! And the smiley face.
Can you try with the other font?
Let's try. I think it's worse. First we have to, let's restart. Let's put the breakpoint here. No. Yeah. The copyright looks like the smiley, and that's it. But the Bulgarian text is displayed. Let's try to copy this. Actually, that won't matter much. Yeah, because the text is actually correct, but the font doesn't support. Let's return to normal fonts. And actually that was a mistake, because we can't see anything. So for now I'll just change the font back to Lucida. Okay, so that's what we see for now. Now we'll print the floating point number. As you can see, it produces it with a dot. We'll go to the invariant culture and print it again. It's still a dot. Let's try to change the culture and see if we can change the number. Console. Okay, so you can see that on my system right now, the invariant culture, which I think is set to English, prints out the value with a point, with a decimal point, with a dot. And once I change my thread culture to Bulgarian, that's the Bulgarian of Bulgaria. One part is the language and the other is the location. So the other Bulgarian-speaking countries might have different encodings. We can see the output becomes a comma. And actually this comment is wrong now because the current culture is Bulgarian. That means that parsing an integer should be with a comma. Sorry, not an integer, decimal. So it is parsed correctly, even though I entered it this time with a comma from the console. Cool? All right, let's see some more if we have.
I have a question. If we don't set the culture,
It will be our default operating system culture. That's the next example in the list of examples. Printing a letter, okay. So we have an application that reads the person's name and the company name and just prints a few lines and specifying replacement arguments inside them. Very cool. So we'll just see it very quickly. That's how it works. And we can see a very nice letter. Telerik has chosen you and all that. I think the code here is quite understandable. The only thing here to notice is that we have a few strings which are concatenated with plus signs, and once we have arguments and variables, they could be in separate lines just for more readability, to make this long string be split nicely for the person who reads this code, and that's it.
The other thing that we have to assign the variable after the string that we're using. I mean, you're using with 0% after that you're using today.
Yeah, these are different right line statements. On each one you have the right line statements are actually, they're not statements, they're function calls, and they live between the two round parentheses.
They are not living in the strings. I mean, if we write in the first string, we enter 0, and then we add the company, for example, of person, and in the next one we are adding again 0, and after it we are adding the other variable.
0 is the first variable.
I mean,
in this,
when we are concatenating the strings.
yeah. So you mean that there are two instances of 0 here in the same string? Yeah, they will be both replaced by the same variable. So here it will appear the company name, and here it will appear the company name. Even though actually this is one big string, it's just cut in pieces, and that's it. It ends here, and then we are moving to the next argument with a comma, and that's it. Just like here. So this could be something like this. Two strings concatenated by plus sign. Not quite like this image, but it is a letter nevertheless. All right, this example is again trivial, repeating what we know, reading from the console two integers and parsing them and calculating, putting the expressions in right lines. Anyone has anything to ask about this?
There is no exceptions.
There's no exception handling here. It could produce an exception, and there's no try parse, so this is not a clean program, let's say. So here it is. Let's run it first with valid data. So it's not very well explained, I think, in the text which is displayed to the user, but he's expected to put two right lines. That means he's supposed to type one number, press enter, and another number, press enter. Press 1 for rectangle, 2 for triangle.
When you press 3, there's
Let's see.
it's not handy.
Well, it did something. Yep. So actually there is no condition here. It just takes the data and puts it into the expression. So if you put 500, it will still work. But
you have a choice even. There is written a choice between 1 and 2, you don't have a choice.
Yeah.
You are using rectangle.
Well, you're using rectangle when you divide by 1, so it's only A times B. But, okay, very interesting example, or not.
If you type 0
What will happen?
for rectangle or triangle,
Mm-hmm.
Divide by 0 exception.
Most probably. Uh-huh. Why?
it calculates it as a float number.
Yeah.
No, because we are dividing by 0, so it's dividing the infinity.
Yeah, it gets the double dot infinity value. If this thing was not floating point option, then we'd crash. And the better solution here would be to wrap this kind of code with try and catch division by 0 exception or any other exception. And
I have a question. Is there a way to program a type of data? I mean, for example, here we need to enter 1 or 2. Can we program some type of data which can be only 1 or 2, and then we handle with the exceptions? Or we can, or we need to
you
use
could.
if.
You could make your own class, which you could check. You could check its constructor, and you could see whether the data is valid according to your rules. And you could play with this. Yeah.
We need to set some type, which is, for
Mhm.
example, we are using sex type,
Mhm.
which means male or female.
Mhm.
And you are entering only small m or
Yeah.
okay. This is the for option.
Well, for male, female, for example, you could produce what's called an enumeration that will be parsed as a certain string or a certain string parsed into it. If it's a numerical value, you could also produce your own class with your own rules, with your own functionality, and you could throw exceptions according to you. You could make your own parse methods that could throw exceptions whenever you need. So,
According to the type of data.
yeah. Seen that. So, this is what we've seen so far. The read, write, read line, write line, read key, all the parsings, and all that. I wanted to show you, first of all, I really recommend you to download the demo of this lesson's samples from the Academy site. It has this solution with all these projects, and there's quite an interesting one called Just Snake, a console application game, which when you run it, it's the snake game that reacts to the arrow keys, and it's really playable. Yeah. So I recommend you to download it and have a look at it. The code is not extremely complicated. You could see, for example, that we have a loop here which reads a key in quite a similar manner to what we saw earlier. This loop tries to see if the user pressed anything and then produces the next step on screen, whether the snake is moved or set a new direction, or then it sleeps and goes on to the next So I recommend you take a look at it. It's very neat, very cool. One more example maybe to see. Actually, I'm missing it. Where did I put it? Okay. I wanted to show a few more samples of string formatting. So this solution is not a part of the demos, but I'll try to share it somehow. Maybe I'll ask Nakov to upload it. What I wanted to show here is a few functions which are related to formatting strings on screen, which works well in the console. The first one is a method which is handling strings, the string itself. Once you have a string, you can pad the string with a number of spaces to the left or to the right. That's good if you want to straighten, if you want to align text on the screen. For example, I have here two variables with strings. One of them is long and the other is short. And I want them to print inside a normally preset width on the screen. We have here one vertical line and another vertical line, and between them I put the variable, but I'm padding it to the left with 20 characters. So it will take 20 characters and it will place the name inside it. The effect will be this. You see that the first line well, it's hard to see it all, but you could see that the first line is padding the name to the left, and it keeps the same width as the second line, padding it with the same width again to the left, and this one is padded to the right but with the same width. So what we get here is a well-ordered alignment of the text.
What is going on if the variable is longer?
I think it will get pushed. But we can try. Yeah, obviously it will push. The next example, one more thing that there is here to note is that you can change colors of your console applications. There is the foreground color property and there is the background color property. So here I'm changing the text color. So the next example will be printed in red. Let's put the breakpoint next. As you can see, what it produces is exactly the same thing, but it does it differently. This is another way of formatting your string. That means pad my string with 20 characters of space. If it's going to if the number here is positive number, it will be aligned to the right. If it's a negative number, it will align to the left. So the effect is actually the same as padding the string, but this is done directly inside your argument definition. A few more examples with what you can do with numbers. Now we're on the yellow example. So I have a number which is a decimal floating point number, and if I just print it out, it will be printed as is. But I can also play with the number of digits before and after the dot. If we have this format, 0.00, it will take 2 places after the dot and it will round the number and print it out. if our number is shorter than 2 points, it will still appear as 2 points after the dot, so 10.1 will become 10.10. Another option is to use those pound keys, which will cut our number by the number of digits that we specify.
It's the same as 0? Or it's rounding?
I think it's changing. I think one of them is rounding and the other is not. But it's hard to see here because it would be rounded down anyway. We'll try to see it in a minute. Another option is to use the comma separator here, which produces the 1000 separator. So my number will be printed as the same number with 1000 separator. These are good for if you want a nice presentation of big numbers on screen. And the other option is to break down the number into digits just by putting the pound key. So if I put here any kind of text, it will break the number and it will be displayed nicely, for example, like a phone number. The blue example what you can see here, why is this, is that you can actually put any text any text that you want inside your replacement argument. So in this case, I'm taking the math.py and I'm rounding it to 2 digits after the decimal separator. But I can also print text here, and the output will be printing the text with your variable. This is a more extreme example where I'm taking a number and I'm putting it here. Here's my decimal separator, the point, and this will be the whole part of the number, and this will be the decimal part of the number. So it's broken down into 2 pieces, and between those pieces I'm putting a text. So this is what it will look like. Quite extreme, but it's good to know that this exists. Now this example I've copy-pasted. I'll show you from where. You can see that there is an option, there is another data type that we haven't mentioned, which is many times used in .NET, called datetime, that can contain a timestamp. That means a date and a time. So we're producing here a date and a time. It's 9th of March 2008 at 6:05 and 7 seconds, I think. Not yet. Yeah. So that's the date and time, and you can see that you can format out any part of your date time variable as, so for example, the year could be in 1 digit, 2 digits, 3 digits, 4 digits. The month could be displayed as a number or a string. These are also things which are determined by your culture, your thread culture. So if you change the culture, those should also get the right month names by the culture. So if we were in Bulgarian, it should be printing them the Bulgarian names.
When we are doing the date time, again, is it depending on the culture?
No, the date time itself is just a data storage variable. So it's just a data type. It's just
so
for...
Year after that date.
So here are all the examples of, these are just the same properties of the date time. So I could actually produce myself here a string formatted in any way that I want that will contain the month, the date in any order, and you can just play with that. It's quite useful. These things are not only for command line. These are not just for the console. Those things can also help you format strings in any application that you write. If you're dealing with window applications, you can just use the string formatting for constructing your string. This is, right now it's just printing it out to the console, but these methods and all that you see here is also useful when you are building strings for any other application, whether it's web or it's WinForms or any other. And the last thing to see here on the white sample is that you can also set the location of your cursor in the console. So what I'm doing here is I'm keeping the top and left position of the cursor first, and then I have a loop here that has just a countdown, and at any iteration of the loop it just brings the cursor back to where it was and prints out a string at the same location, at the same position. Then sleeps, reduces the counter, and does it again. So when we run this, we can see that the counter is running, and it's actually, yeah, it's less impressive than the snake game, but it's but it's in colors. But the snake game is also in colors, so the snake wins.
Did you code it, this one?
Yes.
So easy.
So you can see that here I'm also reserving 3 places, and I'm aligning my text to the left so that the counter, if I hadn't done that, we would still be seeing the previous digits appearing after the 0. So because the number becomes smaller and smaller, and it also becomes shorter on the screen, and it would be not overriding the 3-digit space. And the last line resets the colors back to their original value, so that it resets the console back to gray and black. I'll try to share this application somehow. There is a website that I warmly recommend you. It's called, this one, C#examples.net. It has many samples of code in all kinds of fields, and I don't know if there's a search here, but this is where I got the sample regarding the date time with all the formats. So if you're looking for code samples, that's a good place. The last sample I'll show you is just a small application. Actually, I built it here in order to run a process in the system as a user, as a different user. We won't get into the details of this. This application has it checks and analyzes command line arguments. So let's run it from a console. So it has a nice display if the user hasn't entered any arguments, and it can analyze those arguments and give you a nice fail message. One of the arguments that I've put is /nyan, which produces the nyan cat on the screen. And that's important because since you are all geeks, you have to know nyan cat. And if you don't know, that will be part of your exercises. Okay. So, I think I think we're done here. So, any questions so far? This whole lesson is, of course, recorded, and all the samples, including all the additional samples, will be available on the recorded lesson on the Academy site, I guess on Monday. Any more questions? Yeah.
Which value calls the cursor visibility?
There is a cursor visible Boolean that you can set and hide or show the cursor, or check if the cursor is visible or not.
Well, in C++, there's a visible value, and how wide you want to be.
Yeah, I remember that. Actually, I'm not sure. There is a cursor size, yeah. Integer. By the way, you can see that Visual Studio gives you a lot of information here. It gives you an information about what type of property it is and what kind of exceptions it could also throw. So if you're coding any change here, you can also take into account the right exceptions, which is cool. I recommend you that if you're using console applications, if you want to make them cool, just explore the console properties and methods. Any more? All right, let's get you guys some refreshing coffee, and then we'll have an exercise session.